Hi, this is Gabe from Game Logic, and this video is a tutorial on how to make a basic 2D click and move movement system in Godot. Here's an example of what we'll create by the end of this video. This technique isn't too complicated, but it took me a while to figure it out. Because I couldn't find any tutorials online while I was making it, I've decided to make a little tutorial of my own. Alright, first let me introduce you to the project that I have set up here. We have a level scene, which will be our main scene. We have a ship scene that's instanced, that's just composed of a 2D node and a sprite. And we have a path scene that has our path 2D and our path follow 2D. That's also instanced into our main scene. Alright, let's start adding some code. We'll attach a script to the level scene and declare our variables. This variable target will hold the position of our mouse click. Alright, so what we have here is the function input, which just collects the input. Don't forget to add this, by the way, in your project properties, project settings in the input map. If the event left mouse is action pressed, then we'll add 1 point first to the curve at the ship's global position, and we'll add a point to the curve at the target position. Important here is the toLocal function, because the curve only accepts points in its own coordinate system. So you have to convert the global position of the ship and the target to the local coordinate system of the path node. Before pressing play, make sure in the debug settings to turn on visible paths. And now if we press play, nothing will happen. And that's because I forgot to capture the mouse position. Target. Alright, that should work. There we go. Now it adds points to the path every time we click, but we obviously don't want this many points, so we'll have to fix that. The way we'll fix that is by calling clear points every time the mouse button is pressed. Now we only get 2 points on this path every time we click, which is an improvement. Next we'll add the movement logic in the process function. Alright, so here we declare a variable and make it a reference to the path follow node in the path scene. In the process, we check if the input is spacebar. If it is, we set the ship's global position equal to the path follow's global position. We use the progress ratio property of the path follow to move it, and if you want the ship to move at a constant speed regardless of the path length, then we use just progress, but I'm just going to use the progress ratio. Alright, this works. It only moves every time we press the space button. That's not what we want, so we're going to change this to action press instead of action just pressed. Now when we hold space button, it will move. Notice how the speed of the movement is dependent on the length of the path. And there's a couple other issues here. As you can see, it's jumping, which we do not want. And it's also facing the wrong direction. To fix the jumping, every time we press the mouse button, we'll reset the path follow progress to 0. Alright, as you can see, that still does not work as intended, and that is because we are setting it equal to 0, the progress ratio equal to 0 after we clear the points. The solution here is to just switch these, and hopefully that is better. Yeah, that is what we want. Now we'll try and fix the rotation. If we just set the ship's rotation equal to the path follower rotation, it will rotate the ship, but not in the direction we want. It will always, I'm not sure why, but it'll always rotate it 90 degrees too far. To fix that, we're just going to subtract 1.57, which is 90 degrees in radians, and now it'll look correct. Now it'll always point towards the target, which is nice. We're getting closer to the functionality we want, but there's still a few things missing. For one, if we hold onto the mouse for too long, it'll respawn at the beginning, which we do not want. We want it to stop at the target. So we will add another if statement here in the process. And this basically says, if the progress ratio goes past 1 in the next frame, then you do not move the ship. So now if we move it, it won't go past the endpoint. This looks pretty good, but we still want our curve. We want the ship to move in nice round curves, like a ship would. We need another point, another point in space to add to our curve to get the Bezier. We'll call this one the curve point. We will also need curve distance. We can set this equal to 250, which is pixels, 250 pixels. And to generate this point, we will use a bit of geometry or trigonometry and the sine and the cosine function to find a point, the curve distance in front of the ship. And we'll use this point in the second argument of our second add point function. And we have to subtract target from the curve point because this point we're adding isn't actually local to the path position. It's local to the target point here that we created. And we do now get a nice curved movement. But there is one small little issue still, and that is the little jitter that you can see every time I change the path. Ship does a little jitter. Maybe you can't see it, but it is a little jitter, and you can see why it's doing that because the very first segment of the path is pointing the wrong direction. So it does a little rotation right at the beginning. And there's two ways we can fix that. First is we'll add, instead of setting this to 0, we'll set this to 0.01 so that it kind of skips the very beginning of the path. And then we'll also add an out argument here. We added two more arguments to this add point function, and the third argument is just a small little vector at the back of the path that straightens it into the right direction. So hopefully it should look a little better. It shouldn't have so much jitter. You can see that it does look better now. I do have a few ideas on how to take this movement concept further, such as the ability to add more points to the path in order to create a more complicated movement shape. In a turn-based game, a system to control the speed of the ship could be implemented by using the getBakedLength method or the point count property of the curve 2D. It would also be interesting to use the angle and magnitudes of two adjacent point/vectors in the path 2D node to prevent the ship from taking unrealistically sharp turns. If you'd like to see any of these features implemented, or if you have any suggestions or questions for me, I'd love to hear from you in the comments below. If you enjoyed this video or found it helpful, please consider liking and subscribing. I am planning to create more videos about Godot. Thank you for watching, and I'll see you next time.